All right, let's talk vectors in R. Just some related reading from the Hadley Wickham's textbook. A lot of my examples come from that textbook, so I just want to make sure I give credit to Hadley Wickham. Okay, the most important kind of family of objects that we have in R is vectors, and we have two types of vectors, atomic vectors and generic vectors. We'll just call them lists. Basically, in an atomic vector, all the elements in your atomic vector have to be of the same type. You cannot mix different types of values in your atomic vectors, whereas in lists, you can have different types of things in there. And this is not a vector, but null is a value that we use to kind of represent zero length generic vectors. We have zero length vectors that are of a specific type, but null also is used to kind of represent things that just don't exist. And I'll talk about null and special values in the future. All right, as far as atomic vectors go, we have 6 different types, although there's really only 4 that we commonly use, but we have logical vectors, double, integer, character, and those are kind of your 4 basic ones, but we also have complex and raw. Okay, logical is for like true false values. Other places call them like Boolean values. Okay, we have 2 numeric things. Okay, we have floating point numbers, which are double. If you ask type of, it distinguishes between double and integer, but mode will always kind of return numeric. So integers are for whole numbers. Floating point numbers are called double for double precision floating point. So if you ask mode on those things, you get numeric. And then you have character for strings, and those are primarily the ones that we'll be dealing with. So as far as our numeric types, we have double and integer. In the conversion, kind of flipping between integer and double, is often done automatically in R, so a lot of times we don't have to worry about it. Okay, there is an important difference in that type double is numeric with floating point precision, meaning that when you have like decimal values and things like that, they are not precise. And so if you do something like 1 divided by 3, that is not going to be exactly equal to 1/3. It's it's kind of like if you try to write 1/3 0.33333 in decimal form, eventually you're going to have to stop writing 3's, and that's not exactly 1/3. So if you need to represent this quantity 1/3 exactly, the only way you can do it is you have to kind of store 2 integers, a 1 and a 3, and you have to know that what you're trying to do is you're trying to do 1 divided by 3. But as soon as you actually try to write 1 divided by 3 in the computer, it's going to store this approximate representation of it. Okay, the default numeric type is double. If you want to, so if you write like the number 2, that's going to be a type double 2, a floating point representation of the number 2. If you want an integer, you write the capital L after it. So 2L is going to be an integer 2. And then when you use the colon operator, it just kind of creates a vector of integers. So if you create a vector with 1, 2, 3, that is going to be type double. So if you ask type of on this, you're going to get double. Whereas if you create the same kind, what we might think as equivalent, 1 : 3, which is going to be the vector 1, 2, 3, using the colon operator is going to be an integer. Okay, the number 1 all by itself is going to be a type double, whereas if you want an integer, you write 1L. Okay, and we also have these functions is.double or is.integer, which return true false values and let you know if it's a double or an integer. R does what we call coercion, meaning that it will kind of convert or coerce values from one data type to another when you combine them into an atomic vector. So again, atomic vectors, everything has to be of the same data type. And so if you try to combine values of different data types, some of the values will get coerced so that they can be combined. The way it works is it goes from, it coerces the more restrictive data type into the less restrictive data type. And so in order, you have logical, integer, double, character, from most restrictive to least restrictive. And so here I've got vector L, which contains the logical values true and false. I contains the integer 1. D for double contains double values 5, 6, and 7. And character CH will contain the characters, character vector with the character string A and character string B. So here I'm going to combine the logical, the integer, and the double vector. And what's going to happen is the logical and integer values will get coerced into type double. So type of on this thing will be type double. If I combine the logical, double, and character together, everything is going to get coerced into type character because character is the least restrictive. And so the type of on this thing will return character. So we can see what happens. So when we combine the logical, integer, and double, that returns type double. And look what happened to the logical values. We had true and false. The logical values got coerced into a 1 and 0. The true got coerced into a 1. The false got coerced into a 0. Okay, the integer 1 remained the integer 1, and then the double had the 5, 6, and 7. When we combine the logical, integer, and character, those logical values true and false got coerced into character by just putting quotes around the value true and the value false. Those got put into quotes. The integer 1 remained the integer 1, but now with quotes around it. So now it's the character 1, and then the character AB is character AB still. So that is type character. Coercion often happens automatically whenever you use an operator that expects values of a certain type. So if you have a mathematical operator like the plus sign or the log function or absolute value, that's going to coerce things into whatever it needs to, some kind of numeric type to be able to conduct that. Okay, you have these logical operators like the and the or thing or any, and that's going to coerce things into logical values. So here I have this logical vector false, false, true, and if I explicitly coerce it using as.numeric, that will turn false, false, true into numeric value 0, 0, 1. Okay, if I call sum, which is a mathematical operation on trials, what it will do is it will coerce false, false, true into 0, 0, 1 and add those up, and we get a sum of 1. 0 plus 0 plus 1 is 1. Or mean basically converts these things into zeros and ones and says, hey, what's the mean of 0, 0, and 1? And we get 0.333, which is handy because that's basically the proportion of values that are true. Any of these things you can explicitly coerce using as dot the type. So you can do as dot character, as dot logical, as dot numeric, or whatever, which is basically going to turn it into type double, and it will do it. So if we take, again, false, false, true, and say as dot character, now we get the characters false, character false, character true. If we take the integers or the numeric values 0 and 1 and coerce them into logical, we get the 0 becomes false and the 1 becomes true. If you try to do something that doesn't quite make sense, like I'm going to try to make the characters string dog into numeric, it's going to say I don't know what to do with that, and we get an NA for that, NA for a missing value. When you call as.logical, basically 0 becomes false and everything else becomes true with the exception of nan. Okay, so nan becomes NA. But if you try to say, hey, I want as.logical 1 becomes true, that makes sense, but so does -1, 0.12, negative infinity, a really big number, or really small number, those all become true. So anything 0 is false, everything else is true. NaNs become Na. As far as coercing things into logical, as far as false and true, these are the accepted spellings of false and true. You can use a capital F, all caps false, capital F, lowercase ALSE, or all lowercase false, okay? And then these get coerced into true, and these are all accepted spellings of true. Okay, if I do F and T, lowercase f and t, those are not accepted. So if you call as logical on that, we get an NA. Other words like cat will be NA. What's happening here is 0. If we call as logical on 0, we normally get false, and as logical on 1, we normally get true. But here what happens is the 0 gets coerced into character 0. So imagine quote signs around the 0. And that just happened right as soon as we ran the combine function here. So the 0, so quote 0, 0 in quotes is not accepted as a logical value. And so that becomes NA. And then again, 1 in quotes as a character also become NA. So those are, that's that for atomic vectors. Let's talk about lists. Lists are generic vectors. We can think of that as an ordered collection of objects. Lists are basically the most flexible object in R, and the components that you put inside a list can be really any object in R, including other lists. So if you think about this, we have these one-dimensional structures, and if everything has to be of the same data type, that's an atomic vector, and if you can have different things, we call that a list. If you have a two-dimensional thing, if everything's of the same data type, a two-dimensional structure we call a matrix. If we have a two-dimensional structure where the columns are different data types, that's a data frame. And you can have higher dimensional things, and in R we call those arrays, and they only exist for when everything is of the same data type. So here is a list. This is a list with 4 elements, each one being a different vector. So I create a list 1 through 3. That's going to be integer. So when you can ask for the structure of that data, that object, and so I can say, hey, what's the structure of this list L1? And it says a list of length 4, and the first thing in the list is a integer vector with the values 1, 2, 3. The second thing in the list is a character vector with the value A. The third thing in the list is a logical vector with the values true, false, true. And the fourth thing in the list is a type double or numeric vector with the values 2.3 and 5.9. When you use C, which we often think of creating vectors, basically combining things into that, you can also use that with lists, and they will combine several lists into one. If you give C a combination of atomic vectors and lists, then C will coerce the vectors to lists before combining them. Compare that to using list, which kind of embeds lists, can embed lists in itself. So here, L4, I say make a list. Inside that, we have a list 1, 2, and a vector 3, 4. And so when you do that, here we're creating a list out of a list and a vector. And so the result is going to be a list of 2. It says list of, so the first thing in that list of 2 is this list with the values 1 and 2, okay? And then the second thing in the top level list is this numeric vector with the values 3 and 4. So the top level is a list of length 2. The first thing in that list is another list of length 2 with the values 1 and 2 in it. And then the second thing in that top level list is a numeric vector with the values 3 and 4 in it. Okay, compare that to L5, where I am combining a list of length 2, basically this list of 2 with the elements 1, 2, and a vector 3, 4. Okay, and here what's happening here is we're using C to combine these, and so that's going to coerce the 3, 4 into a list, and so the total thing ends up becoming a list of length 4. Okay, and we get the 1, 2, and the 3 and 4 in there. Okay, it feels a little bit odd, but that is the difference between, hey, just make a list out of these things versus combining them with C. These data structures, the atomic vector and the list, can also have attributes. Okay, attributes is a named list of arbitrary metadata. Basically, you can kind of include whatever information you want that you want. Now, sometimes the attributes do carry important information that helps our function, and that will be if the attributes include dimensions, and that turns kind of atomic vectors into matrices or arrays. Also, the object-oriented system in R uses a class attribute, and that is how R is going to handle basically any of the object-oriented programming systems in the S3 system there. Okay, let's just take a look. So there is a data frame in R called trees, and if you look at the first few rows of trees, we see this. It's got information about the girth of the tree, the height, and the volume of the tree. And we can learn about the attributes, okay? The ATTR function is used to get basically single attributes and can be used to kind of get those or also change them or set them, okay? Whereas the function attributes all spelled out can give us basically the entire list of attributes. So again, here's that data frame trees. We can ask, what are the attributes of trees? And what it gives us is it gives us the names, the class, and the row names. So it says the names are basically the column names, right? The class is that this thing is a data frame, and then the row names, well, it's just this vector of integers, and those are the row names, basically rows 1 through 31. Okay. If you want to, you can set attributes. And again, because attributes are just an arbitrary list, you can throw in, whatever information you want. So if I wanted to throw in an extra piece called info, and say this data frame is about trees, you could do that. This is not really normal practice, probably not something we would do in real life, but attributes in R are just a list, and so doing something like this is possible, and it just kind of tacks on that additional information. You can kind of think of, you have your object, your data frame, your list, whatever it is, and attributes is you're basically just kind of stapling on a little piece of paper with additional information, and you can kind of write whatever information you want on that piece of paper. Other things you can do with a vector is you can provide it names, and these will get kind of stored in the attributes. So here we can create a vector, right? And when I create the vector, I can give it names. And so we have the elements 1, 2, and 3, but those elements come with names. So the name for the with the value 1 is A, and the element for the value 2 is B, and the name is C for this third value. Okay, and that's going to do that. We can create basically the equivalent by creating a vector, integer vector 1 through 3, and then providing, I can use this function names x and give it a character vector and give it the values A, B, and C, and that will assign the names A, B, and C. Okay. There's also set names, which is another function, and this will take, say, the values here, 1, 2, 3, and I'll also set the names A, B, C, kind of respectively to the elements in there. If you want, you can get rid of the names using unname, and so that will basically simplify your vector just down to an unnamed vector. Or you can take names and set them to null, and so that will get rid of them. Okay, and again, if you have something like a data frame, names will be things like the column headings, but if it's just another vector, it'll just get stored in the attributes, and it will be the names of the, whatever elements you have in the atomic vector. Okay, so that's what we have to say about vectors.